Now, this is just a reminder of what we did before. You have the whole thing, the electron configurations. The only thing that's going to be different here is that you're going to literally draw the spin of the arrow. So, for example, S, you can every single blank can have up to 2 arrows, one going up and then one going down. So because 1s has 2 electrons, you only need one blank because you're going to have one spin going up and one spin going down. Okay? Now, for the P, since I can put 2 electrons in each thing, how many blanks am I going to need? I have a possibility of 6, but 2 can go into every single blank. So how many blanks do I need? 6 divided by 2 is 3. Okay? So now the difference here is, let's do 2p2. Okay? Or you know what? Let's do over here 1s. I can have 2 arrows. One's going to go up. One's going to go down. Remember Hunt's and Principles rules, the definitions that we did? Here you have S again, so you only need one blank, because this is 1s, this is 2s. How many arrows am I going to have? 2. So one's going to be going up, and the other one's going to be going down. Because this is a P, even if I don't have more than 3 electrons, because I have how many? I have 2. I still have to have the 3 blanks, because once you open that orbital, remember your atom is in the middle, and once that energy level is open, here I have my 1s, here I have my 2s, my 2p, and it continues going that way. Once it's open, so I have all 3 blanks, but I only have 2 arrows, so I must do all of the arrows up first before I can do any down arrows. Okay, so this would be your electron your electron orbital for carbon. Okay, you see how it goes right with the electron configuration? That's what's telling you how many arrows you're going to have. Okay, now if I had D, I have 10 possible electrons. How many blanks am I going to need? Remember, 2 arrows can go in every single blank. So how many would I need? 10 divided by 2, 5. Very good. Okay, so 1, 2, 3, 4, 5. For 14, for F, how many blanks would I need? 7. So 1, 2, 3, 4, 5, 6, 7. Okay, because every single blank can have up to 2 arrows. But remember, the arrows that go up first, those spins must go first before you can have the bottom arrow. Okay, before you can do, that would be 1, 2, 3, and then this would be 4, 5, and then P6. Okay, we see that? Yes? Okay, let's do another one. This is hard? How's this hard? Let's do number 1. What element do you have for number 1? K? Okay. Let's add another page.
So on this paper.
Is
that how all of them are going to look on this paper?
Yes, so if you have K, let's do the electron configuration first. K stops where?
4s1.
On the 4s1. So remember, that's going to be our stopping point. So let's start from the 1s. What's my electron configuration? 1s2. Then 2s2. Boys, what's next?
2p6.
2p6. And then what's next?
3s.
3s2.
3d.
Oh no, you're still in the third row, so 3s2, go down your alphabet formula. What's next?
3P.
3p, how many?
6.
3p6. Now you can go to the fourth period, and it's what?
3D.
You're going to be in the fourth period,
That's not
4s1, because that's your stopping point, right? Remember, Mija, your charty pass?
They didn't have one. I was helping with student council, so I have a pass on it.
Okay. Remember that your objective here is to, you're going to get the configuration first, that way you can do the orbital, okay? All right, so how many blanks am I going to need for the 1s?
2. Oh, no.
Because S can have how many, it's going to have how many arrows?
2.
It's going to have 2 arrows, but how many blanks do you need?
1.
1, okay, because you're going to have 1 arrow that goes up and 1 arrow that goes down, because that's your full shell, right? Okay, so for 2s, you see how you're just following the next step? How many blanks am I going to need for 2s?
1.
I'm just going to need 1 blank because it's an S. And I have how many arrows?
What do you mean by blank?
This is your suborbital, okay? Think of it as your suborbital energy level, okay? That's where your arrows are going to go. So how many arrows are going to go in there?
2.
2. 1 going up and the other one going down. Because remember, in each suborbital, you're going to have 1 arrow going up, the other one's going to be going in the opposite direction, it's going to be going down, like that, okay? All right, so now you're going to 2p6. How many blanks are we going to use there?
2.
3, because it's a p, and you can have up to 6 electrons. So tell me how that's going to look.
Up, down, up.
I'm going to have 1, 2, 3. Now I can do the 4, 5, and 6. Okay? You see how we do the up arrows first and then the down arrows? Yes? Okay, now you're going to do the 3s. It's an S, so how many blanks do I need?
2. 1.
I need just 1 blank. Okay? And how many arrows am I going to have?
2.
1 going up and 1 going down. Okay. Now my next one is a P. So how many blanks am I going to need?
3.
3. Okay. So how am I going to do my arrows?
Up, down, up, down, up, down.
Remember, you don't do up, down. You do up, 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 and then down, down, down. Okay? You cannot have something like this, David. You cannot have something like this. Okay? That would be an incomplete. You have to have all the up arrows first, and then you can do the down arrows.
How would you know, though?
Because this number is going to tell you how many you have. That's a good question. Guys, if it was a P4, you would still have your 3 blanks, but you would have 1, 2, 3, and then 4. Okay? So remember, you're going to count all the way across and then start going down. If you have something like this, it's incorrect. We see the difference? David?
Yes.
Yeah? Okay, you have to fill in all of the blanks first before you can start doing that down arrows. All right. Huh? Mijo, you'll have to see if there's an extra one. If not, use the book one. Okay, I tell you guys, that periodic table, you're going to need it every day. Okay, so now what's next?
It's the 4s.
The 4s. So how many blanks am I going to need?
1.
Just 1. And it's going to have how many arrows in it? Just 1, yes. So my up arrow. Okay? And then that's it. Bless you. Bless you. Okay, you see how that's left as an open shell? Because you don't have the two electrons, you only have one, and so that's why it's going to be left with only one going up. Okay? Where do we have a question? Tell me an example. You see how you're just following the electron configuration? This is telling you what to do. The electron configuration. Every time you have an S, you're going to have two. What if I had an element that had ended with a D4? You still have to have all 5 blanks. 1, 2, 3, 4. And even though it's empty, you still have to have that empty spot because it's an open orbital. Okay? Even if you had a D2 and we erased and we only had 2 electrons, you still have to have all 5 blanks because it's a D. Okay? Because it's a D, it's in the D section. All right? Yes? Okay, what question do we have? Remember, your first objective is you're going to give me the electron configuration like normal. And then you're going to use that electron configuration to find your orbitals, your spins. Okay, are we sure we have no questions? We positive? Okay, I'm going to post it just